wrote out if we were given, we have if we're given midpoints, we have if we're given perpendicular, and then I think we have angle bisector. I think those are the three that we have as of right now. But there's a couple other ones that will show up from time to time, and they really can happen with any style triangle proof. For example, in this case, what are they giving you right away? Yes, sir. Exactly. They're giving you that you have parallel lines. Now, when you have parallel lines, that means that from last chapter, recall that we had all those different angle pair relationships that can happen. So we have to figure out, how do you write that in terms of a proof? How do you write that in terms of a progression, if you will? So what I want to do real quick is switch to a square before we write this all out and walk through what in the world do you do when you are given parallel. Yeah, just put it in another square. Just put it in another square. What I mean by what we have to look for the given parallel stuff. So when you're given parallel lines, that means that you have one of those four angle pair relationships that happen. So what you want to do is you want to look for an angle pair relation. Alternate interior, alternate exterior, corresponding, and consecutive interior. And to be honest with you, the ones that you will see more often than not with triangle proofs are going to be alternate interior angles and corresponding angles. It's very rare that we have to worry about what alternate exteriors look like in a triangle proof, or corresponding or consecutive interior being supplementary. It doesn't really get you very far with a lot of those, to be honest with you. So in my mind, I would do something like this. I would draw what they look like. That way we remember what they are. We do? Oh, okay. So I didn't know if this class we did. I know we did it in one class. I didn't remember which one it was. So I apologize for your rewriting. But if you have that already on there, fine. We're just going to add a little bit to it of what happens. How do you write it? Okay. So what I mean by looking for these angle pair relationships, it's how you would put it in a proof. Then is something like this. You could say if blank. If you have alternate interior angles, or sorry, if, oops, if I can make this work. If two parallel lines are cut by a transversal, that's what that symbol means. If two parallel lines are cut by a transversal, notice how it's got the arrows on everything. You have to put arrows on all of it, because if you don't have arrows on it, it looks like it's not equal sign. Okay. If two parallel lines are cut by a transversal. So if you want to write out two parallel lines cut by a transversal, by all means, or you can just make that simple. All right, so if you have parallel lines, obviously there's some sort of a transversal, then an angle pair happens. And it's going to be one of these. Okay? Now, it's kind of a difficult thing to show you guys that it's always going to be the same setup as far as progression is concerned. But once you see an example within the proof like we just had a second ago, it's kind of that same scenario. It's kind of tough where, a midpoint segment converts segments, always the same thing. Angle bisector, angle equal, angle congruent to angle. Perpendicular, right angles are formed, right angles are congruent, things like that. This one you have to actually figure out which of the four occur, right? So we'll go back here in a second, and then I'll put up on double here. If you haven't finished writing out the given and prove statements for this one and draw the picture, go ahead and do that as you finish that out. And I'm going to walk you through what do you look for, what do you write up when you see parallel lines cut by transversals. All right? Let me know, did everybody get the square stuff done? Is everybody on the square? Then I'll put it on a single page. Now, what I want you guys to look at is we're going to write out what's going to happen. All right? So we'll finish writing up the given and proof statement on that, and we'll walk you through. You good? Your first step in a proof, after you've written down your given statements and drawn your diagram, is to write down in the proof your first given. It's a good place to start. AB parallel CD. We mark our diagram. Now, at this point, you'll notice we've got two parallel lines. That diagonal of BC acts as a transversal. So when you start thinking about angle pair relationships, you have two parallel lines cut by a transversal. Which angles become congruent to each other? Which one? You're close, but you're looking at the outer edge here and the outer edge out here. I can't get to this outer edge because it stops. See what I'm at? And this one, how it stops here, so it's not going to get me anywhere. But what ones that do work, oops, saw that move, are the interior ones like this. See that? As you come through, you're making, you have your alternate interior angles. So when I write that out, I can say that angle ABC congruent to angle BCD, right given. And here's what it, bless you, here's how it looks like when you write out your reason for this. If two parallel lines up by a transversal, then alternate interior angles. It's that whole definition that we used last chapter. What was the angle pair and what happens? The angle pair here is the alternate interior. What happened? They were parallel, which makes them congruent. Unfortunately, there's no way to shortcut that any more than that, or shorthand it out. It's one of those that you kind of have to write out in a little bit more of a long form and go from there. All right. Is there anything else I can do with those sets of parallel lines? Nope. Those two parallel lines just gave me that one transversal that had an angle on both sides. So I go to my next given. My next given says that AB and CD are congruent to each other. Let me clean up my diagram a little bit here. Congruent, congruent. We only have two ways to show that triangles are congruent. We have side, 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 and side, angle, side. Which of these is it starting to show that it's going to wind up being? Which means I need to find another side. What side do these both have in common again? Which is it? All right, think of the two triangles. The two triangles have something in common. Yeah. This is, again, another one of those reflexive sides where it's shared. That diagonal, that transversal, if you will, in this case, is shared by both triangles. It's part of each triangle. So you can say that that segment is congruent to itself via reflexive again. And now your two triangles are congruent because of side and side. So it tells you what it wants you to show. You just have to look and see what you can show to get there. It's the idea of starting with the given stuff. What does the progression sheet tell you to do in each step? And then from there, what else can you get? Well, parallel lines give you an angle paragraph. The given table is there. So really, the only one we had to kind of, this was a little bit trickier. You had to kind of figure out which angle paragraph, but then you had to look at the reflexive stuff. And we're done. This should have been awesome. Try to just get one takes an extra step. Oops, sorry about that. Making sure you guys were awake. We haven't done an angle bisector yet. Let's do an angle bisector. Let me change what it's asking us to show here. Let's prove that we have triangles x by z and triangle x w z congruent to each other. Okay. Eventually, we'll get to doing the parts of triangles. We'll get there. It really has nothing to do with it. For right now, it has nothing to do with it. Later on, it will. We're just not there yet. I just wanted to get an example of an angle bisector. John, put your seat down, please. Thank you, sir. All right. Where do you always start? Given. So you write out your given. We mark our diagram. So we have yx, wx. Zx bisects angle yxw. We haven't seen an angle bisector yet, but I do believe we talked about it on here, didn't we? We haven't done one. So let's make sure we have this angle bisector on our blue part, our blue sheet, okay? According to our blue sheet, we have if given angle bisector, what's your next statement to do? Well, according to ours, it says if given angle bisector, then angle is congruent to angle, which means you have to figure out which two angles become congruent. So in this case, we have ZX. ZX is going up and breaking out. What are the two angles that are congruent? Yeah, Josh. Okay, if you say XYZ, that's this one, and XWZ is this one. ZX is going here, and it's bisecting that angle. Sir, Matt? Oops. Let's see. So ZX bisects YXW. So X is at the top. So it's YXW. So these are the two angles that are bisected, that are cut into equal parts. That's the idea here, guys. You have to have a picture in front of you as you're drawing these out, so you can look and mark your diagrams to figure out which exactly piece you get. Okay? So we write it out. Angle. Y, X, Z, congruent. Angle WXZ. Definition, angle bisector. Again, we're at the point where we have a side and an angle, which means we have to find another side. I can't see my triangle though. Go that way here. Just can't see over your big head. You just picked the wrong seat, man. So, if I want to prove that I have triangles XYZ, XYZ, and triangle XWZ, what side do those two share? XZ. So I have to say that XZ is congruent to itself. Why is it congruent to itself again? Yep. And now you have side, angle, side. It's a matter of going through, looking at that sheet so you don't have to freak out about, I don't know what to do, I don't know what to do, I don't know what to do. And it tells you exactly what to do. Hey, knucklehead, you have an angle bisector. That means some angles congruent to some angle. Why? Because that's the definition of the angle bisector. It's a matter of going through it and making sure you follow through. Did we do one yesterday with perpendicular? Okay, we did perpendicular. In parallel, we've done that. We've done the other weird ones we're going to see today. No. What's it? Yeah, we did that one. Here's what I want you to do. And I'll pull this up on the board if you don't have your Chromebook on you. That way you can add to your homework from last night. It's on the next page, 232. I want you to do numbers 28 to 31. Just 4 more. I'll pull them up. I'll give you guys time in class to start working through on them. No, we did not. You just add these 4 to what you did last night. So you'll have 8 proofs to give me tomorrow. No. Hey, give me a second. I'll pull this up. That way you guys can all look at it. And we'll. There, all 4 of the problems that I'm going to ask you on last night right there. What's that? It's all here, some stuff. Yeah, but it's all right here as well, so you can just look up here and grab it. But I need you guys, when you're doing these proofs, you have to draw the picture alongside it. You got to put the picture on there so that way you can see exactly what you're going to do. That way you know when you have a bisector of an angle, JG, have, that means you know which two angles are going to be congruent to each other. You'll be able to figure out where there may or may not be some overlap or sharing sides and stuff. So it's imperative that we draw pictures to know where things are going. All right? You've got time now to work on it, so like we said, expect you guys to be working.